In this question, what we're asked to do is find the current that's running through the two loops of this electrical circuit. So you might see similar questions that are posed slightly different, where they may ask you to find the current that runs through each sort of leg in the circuit. So for example, you might see these written as like nodes, and then you can see between those two nodes, we could break this into three different paths. It's just a very similar question. They're closely related. This is just asked a little bit differently. So we can break this picture down into two loops, I1, I2. You could really draw it differently and like make the whole outside thing a loop and then have an inside loop. But everything beyond these two is kind of just going to be redundant. And so if we look at this, just sort of the way it's drawn, what we want to do is use those basic principles of electrical circuits and Kirchhoff's law, Ohm's law, to essentially set up the formulas that we need to actually solve this thing. So just kind of jotted down here, the two laws that are really going to govern this. Ohm's law basically says that any voltage drop across a resistor is going to be the current times the resistance. And Kirchhoff's laws, we can kind of combine together in one statement to say that if we're looking across any of these loops, the net voltage drop through the resistors is going to be equal to the net voltage source, which in these pictures are generally going to be batteries. So what we want to do is basically set up our two equations, one for the first loop and one for the second loop. So we could set up I1, and basically what we want here is the voltage drops from those two resistors to be equal to that battery source. So the voltage drop, if we look at the first resistor here, so that's going to be 5 ohms. And it's only in that I1 loop, so it has nothing to do with the I2 loop. And so what that means is it's just going to be 5. And I usually like to use the lowercase i's for these, where like the big I is referring to the loop itself. So I'll use 5I1 for that one drop. And then what we're also going to have here is this other voltage drop that's coming in here. And so that's going to be 10. But now what you want to note is that we actually have the two loops going into this. So if I follow I1's loop, it goes in like this. And so since I'm in I1, that's going to dictate my positive direction. And notice that I2, if I'm going around the loop, it's also going in the same direction. So those two currents are going to add to each other. They're going to contribute to each other. And so what we get is I1 plus I2. And that is going to add up to, it has to be equal to that battery source, which is going to be 10 volts. So we can rewrite this equation a little bit more nicely and say basically 15I1 plus 10I2 equals 10. And you know what, I can reduce this right now and just say 3I1 plus 2I2 equals 2, just by dividing the whole thing by 5. For the second loop, we'll get something really similar. So I'm going to have my I2. And so again, maybe if I want to look at that green one first, because I kind of already have it drawn and I can see that it is part of that second loop. So what I would have is the 10 is the resistance, and then the current is going to be I1 plus I2 there, because again, both of those are going into it in the positive direction, which happens to be the same as I1, but in this case, it's dictated by I2. But then we also have the other current here, which I'll just use a different color. And it's not a part of the second loop. So it's only going to be I2 that contributes to that. So 5I2. And in this case, the battery source is actually just the 5 there. So maybe just so you can see where that's coming from. It's that 5. And that 10 is going to be coming specifically from this battery source here, which was in loop 1. And so again, we can rewrite this as combining it. I can see I've got 10I1 plus 15I2 is equal to 5 in this case. And we can reduce that to 2I1, different than the first one, plus 3I2 equals 1. And if you like, we could put this into a matrix equation, however you want to solve it. But we end up with basically these two equations, two variables, If you go ahead and solve it, they're going to get some fractions in there. But if we do go ahead and solve it, you'll end up with I1 equals 4/5. And our units should be amps or amperes. And I2 is going to be equal to actually -1/5, which is interesting. It is allowed. It can be negative. What it actually means is that just because of what's going on with that second loop, having something to do with what's going on in the first loop and that interaction between the two, it actually is causing this loop to go in the opposite direction of the battery. So that's what that negative there is doing there. It just changes the direction, which is unusual. It's going in the opposite direction of the electron flow, but it can happen just because of the dynamics here. So yeah, that will be our solution.